Hello and welcome to Travel Medicine. As always, I'm your friendly neighborhood internal medicine doc, Dr. J.
Hey guys, Dr. Santhosh here, pediatric infectious disease doc and research buddy.
And I know I'm the friendly neighborhood internal medicine doc, but Santhosh, have you seen the new Into the Spider-Verse with a series of friendly neighborhood people?
I so want to. I've been trying to convince my house full of humbugs to go and see this movie with me, and they don't wanna. And so I am going to have to wait until I have some time. Yeah, I'm calling out my wife and daughters right now. They're like,
Publicly and without
yeah,
fear of reprisal.
absolutely. I'm calling out my extremely famous wife. She has Twitter following too. Like they can dox me. Although they'd be kind of doxing her.
It's the perfect foolproof plan.
Yeah. If my lazy rocket scientist of a wife would please make some time to see Into the Spider, yeah, I'd love to go. What I'm trying to say is I'm not bitter at all right now that you have gotten to see it and I haven't.
Well, I was going to say let's have fun and discuss something goofy because it's an alternate week. But seeing as how you're bitter, I think we need to do something to cheer you up. So let's
Oh, okay, yeah.
let's go half and half and we can do something that may be a little bit goofy, but also involves something you care deeply about, and that of course is shots, 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 everybody. That's right. Throw your hands
Yeah.
throw your hands in the air and wave them around because we very much do care
Hmm.
about Journal Club. Ah!
Hey. Oh.
And this one is going to be dedicated to vaccines, and it may even take 2 episodes because we might have to give a booster.
Oh. I didn't even think of that. That's beautiful. Yeah. So some of y'all, depending on how we space this thing out, might get like a single shot and then a booster, or we might just do, both doses in one.
We do not expect any severe reactions to the
None.
information contained therein. Spontaneous movement of the facial muscles is not unexpected.
Yeah, yeah. Brief, spontaneous exhalations, coupled with joy noises, aka laughter.
Anyway, this journal club is dedicated to updates in vaccines, big vaccines, little vaccines, small vaccines, all kinds of vaccines.
Yes.
And the first one is actually one of the more exciting because it is a kind of virus that is on everybody's mind right now.
Yeah, absolutely. Well, a lot of the North American continent is finally getting over this virus, but it was a horrible, horrible plague this past winter, I should say.
Of course, we're talking about RSV.
Yeah, respiratory syncytial virus. Absolutely.
So the FDA has fairly recently approved the very first RSV vaccine for older adults, which of course is one of the more vulnerable groups. And let's face it, we're all getting older.
Yeah, so there are actually two that I'd like to talk about today, but this first one that you're talking about is from GlaxoSmithKline. And because it's RSV and it's a vaccine with an X, the folks called it RXV. So
All they had to do was put like protein in the title and RSVP. It's hanging right there.
yeah, RSVP. Oh,
Please,
absolutely.
RSVP, please respond. There, I've just done the whole advertising campaign for you. You're
there,
welcome.
there you go. Yeah, this is a beautiful new protein. It is a protein virus, actually, a
Yeah.
protein vaccine.
Oh, you thought I was just tossing that out there?
No, because it's not like the live attenuated vaccines or we use anything like this. This is a protein.
No, it's pre-recorded.
There you go. Yeah, and what we're trying to do here, Josh, is talking about elderly people and, over 65 years old who are vulnerable, especially those who have things like chronic obstructive pulmonary disease, COPD, and heart disease. So if they get RSV associated lung disease, they can go down really quick, a lot like COVID. And we're talking about maybe 60,000 plus hospitalizations a year. And of those, maybe 10 to 15% die, which is really scary.
And this has been around for quite a while. Now, when you think about COVID, as terrible as it was, appeared suddenly, and a
Mhm.
vaccine was developed, comparatively speaking, just as suddenly. But this is the first vaccine for RSV.
There were older RSV vaccines, and this is kind of a scary, it's a scary history for people to take in, but it's important because it actually shows how seriously we take the safety profile of RSV. So we used to actually have an RSV vaccine, I believe in the 1960s. And at first, the protection was really excellent and we were finding decreased cases. But then after that, we found that for whatever reason, this formalin killed RSV. So the whole cell of the virus was killed in formalin and then washed and administered as a vaccine. But the weird thing about RSV is it causes some lung damage itself, but it also provokes our bronchioles, our airways, sometimes to constrict violently because of inflammation, a lot like an asthma attack. And in this case, this vaccine, this old vaccine, actually caused more of that. So it was actually increasing morbidity. We pulled that vaccine, okay, and got rid of it. And for a very long time, because of fear of causing more harm,
But I'm
we,
sure that after we pulled that vaccine,
yeah.
we realized that science occasionally will have these setbacks, and the researchers found what was wrong, corrected it, and we definitely didn't wait at least at least 40,
50.
40 or 50 years before
Yeah.
attempting research into the topic again, because
No.
that would be ludicrous and mean
No.
that we had been motivated by fear.
Well, this is what happens. You're absolutely right. Human beings are a lot more worried about risk than we are kind of chasing after reward or good things. It's just how we humans are wired. And so after that happened, it really did. It scared everyone. And we basically halted any kind of research into it. And anyone who wanted to do RSV research for kids or for adults, it wasn't getting funded or proceeding in any direction whatsoever. So, yeah.
You were right in that you have bronchiolitis in infants. Older adults also just get more susceptible as a result of that to pneumonia, to exacerbations of COPD, and even to heart failure. Having this vaccine,
We did have to take a component of RSV rather than the whole cell, and we took the. You're gonna get so mad, Josh. The actual candidate vaccine is called RSV pre F3, so it's got the P in
oh,
there.
it's
OA.
right.
So,
It's
so
right there.
yeah, it is. It really, really is. Unfortunately, they didn't name it properly. They had to just throw an X in there and call it RXV. But yeah, this is a beautiful protein-based RSV vaccine. And the trials were published in February 16th, 2023, New England Journal of Medicine with Dr. Alberto Papi et al. I absolutely love it.
Aye, Poppy. Well
And
done.
so the single dose decreased the relative risk for RSV related lower respiratory tract disease, so lung disease, by 82.6%. And, pretty wide confidence interval, anywhere from 60 to about 95%. Do you want, hey, really strong efficacy? We're up there. That is really fantastic. And it just to decrease the number of people who would be going into the hospital every year with RSV related complications and save their lives potentially. This is huge. So there is another vaccine that was made by Pfizer, and this one was actually looking at the opposite end of the age spectrum. So little babies, okay, especially those under about a month of age, if they catch respiratory syncytial virus and they don't have protection because of antibody from mom, or they're extra kind of vulnerable to bronchiolitis, which means the small airways just closing up and shutting down. These kids can die very quickly or be hospitalized and have a lot of morbidity. And so we said, okay, well, we need to vaccinate these little kiddos, but we know from experience that their reaction to vaccines is not very strong. They don't have the type of immune system to mount antibodies and this kind of a thing to fight it off. So what do? You vaccinate mama, just like we recommend moms getting their flu shot while they're pregnant and Tdap. And actually, also, Josh, the COVID-19 viruses, the mRNA vaccines while they're pregnant to protect their babies using maternal transfer through the placenta of their antibodies. So Pfizer has developed a beautiful pre-fusion F vaccine, so another bivalent RSV pre-F vaccine. And this one is just about ready to go. The safety and efficacy trials have looked really, really good. However, and again, this is another story of how very, very careful we are about safety profile. There was a very small and insignificant, but definitely visible signal in terms of looking at premature births in the moms who got the RSV vaccine versus those who didn't. So just to let you know how tiny this difference is, the moms in the groups that got the RSV vaccine, 5.6% of them got premature births, and the ones who received a placebo shot, 4.7% of them had premature births. So really thin margin. When you run the statistics, it actually turns out that that difference could have happened by chance alone. But it was worrisome enough that when this went to the Advisory Council for Immunization Practices under the CDC, so the ACIP, the very, very brilliant, smart people there said, you know what, let's hold. Let's wait a little bit before we approve this vaccine and make sure that this isn't a worrisome finding. So it's waiting in the wings. The safety profile looks good to me, and the efficacy profile is excellent in terms of protecting little babies. But I want everyone out there to know how seriously we take any kind of worrisome side effects, even if they're theoretical.
And with that, let's move on to our next vaccine. Now, I told you we were going to have some fun with these. And before I tell you what that vaccine is, we're just going to take it back to the old school because I'm an old
Okay.
fool who's so cool.
Yeah.
How many times have I done that joke? A lot, and not for the last time either. But
yeah.
Santhosh, are you familiar with King Tutankhamun, or if you use the correct mummy pronunciation, Tutankhamun?
I'm very impressed. I don't think I've heard you pronounce that before.
Correctly, you
King,
mean?
sure, absolutely. No, not like that. No, King Tut. You're talking about one of the most famous boy kings discovered in his tomb, I believe at Giza. I can't remember if he was in one of those giant pyramids.
No,
But
he wasn't. He was not. He was
he
found
was not.
by Howard Carter, modern day Indiana Jones. If by modern day you mean one where everybody involved in opening that tomb died. Definitely not of a curse, though.
No, I do know what you're saying, because there were a lot of this was one of the stories that set off the myth of the mummy in terms of disturb these tombs not, lest ye be cursed, kind of a thing. And then you go through the information, and it turns out that most of them died because they got old, and it was perfectly normal, with a handful of
Hey, one
coincidences in
guy
between.
got bacteremia from a mosquito bite,
Yeah.
and a bird and a dog both died within days.
Sure.
and a
Okay.
few
Yeah.
other
A bird
guys
and a dog.
and a few. Well, I mean, but it was the bird and the dog of like Howard Carter and the artist who.
Maybe. Yeah.
Look, the whole story's on NPR. You can go
Yes,
find it,
it
but
is. Yeah.
the far more interesting thing is not what killed the party that opened his tomb, which was
Okay.
again not a curse, in case you were
Uh-huh.
wondering, but what killed King Tut itself. King Tut
Oh.
himself, and that's been a mystery for many, many years. For those of you who are unfamiliar, King Tut is the boy king
Mhm.
because he took over the Egyptian throne at age 10 and died of what were, until this story, mysterious causes at
Okay.
age 19.
So wait, is this going to be a big reveal right now?
Well, we only have so much time in the episode,
Okay,
but
gotcha. Okay.
yes,
Okay,
as big
okay.
a reveal as I can make it.
Sure.
From an article from JAMA.
The Journal of the American Medical Association. Yes.
I want
Okay.
a JAMA with you, Santhosh.
Hey, I want a JAMA with you.
And I hope you all like JAMA too, because it has an article, King Tutankhamun, Modern Medical
I,
Science,
I never
and
put those two together. I cannot believe it. The number of times that I've read JAMA, JAMA, and I've never put that joke together. Oh, that's so good.
in an
Okay.
editorial for JAMA, King Tutankhamun, Modern Medical Science and the Expanding Boundaries of Historical Inquiry, basing on DNA analysis and CT scans, like portable ones. That King Tut died from complications from a broken leg, which normally isn't enough to kill you unless it's exacerbated by malaria. Remember that
Oh,
mosquito that gave the person who opened the tomb a bite that led to bacteremia?
sure,
Well,
sure.
another mosquito was responsible for killing King Tut. Coincidence?
Oh,
Probably.
there we go. Yeah. All right. Gotcha. As long as you include the yes, probably. Yeah. Absolutely.
So, if only King Tut had had access to our next vaccine.
Oh, okay. Yeah. Oh, are we doing a wonderful like anti-malarial vaccine?
Yeah, then he
Okay.
might have lived to become the Man King, which
Yeah. That would have been pretty darn cool. Absolutely. There have been many vaccine candidates for malaria that have been, tried over the years. It is one of those that has eluded us for a while. I believe, Josh, I think there's one that is approved somewhere in Africa for young children. I'm not sure.
yes, I believe we had reported on it earlier in the year at a
Yeah,
different journal club. Yay!
right. I think that one is RTSS-AS01 or Mosquirix. That one was available and it isn't a fantastic vaccine efficacy. It decreases hospitalizations from severe malaria around like 30%. But if you're in an endemic area and you're cutting down, hospitalizations for severe malaria in kids by a third, that's still huge.
Well, would you stick your arm into a box of mosquitoes to get a
Uh,
vaccine?
I mean, if the vaccine is good, yeah, absolutely, yeah, that would be wonderful.
I don't mean in some sort of Indiana Jones, you have to reach through this dangerous nest to get to the shot. I mean like no, you hold your arm in the box while all the mosquitoes bite you
Gotcha. Okay.
because that's what they're doing down at the University of Washington.
Okay.
Although at least in this particular story,
All right.
separate from the
Oh,
working African
s-
vaccine.
so we're using the mosquitoes in this case as the vaccine vector.
So in this experiment, the mosquitoes are infected with malaria, but genetically modified to be weakened to just trigger an immune response, that live
Sure.
attenuated vaccine. This will lead to the production of antibodies when it encounters your system. The point is not to inoculate people against malaria by getting bitten. This doesn't turn you into, Mosquito Man, which would be a terrible superhero. The idea is to test whether exposure to a very weakened form of malaria, such as the amount that could be delivered in a mosquito bite, can provoke a robust immune response. If so, then the genetically modified parasite can be delivered in a single vaccine shot scaled up. But the question is, will just getting bitten by 2 or 3 mosquitoes be enough to provoke this response?
So this is a delivery proof of concept type of a thing.
So, what's the smallest amount that can provoke an immune response? And that's what you can deliver in your vaccine.
Okay, so very interestingly, we're using the little biters here as a kind of a dose response or dose adjustment kind of a device. That's kind of neat.
And this, of course, involved your favorite Santhosh CRISPR. They took the malaria
Oh yeah.
parasite, which,
Okay.
for those of you playing along, is usually a disease of fever, chills, fatigue, sweating. Like anytime you see somebody sick in the jungle in a movie, that's honestly probably what they have.
Yeah. There are a few others that mimic. But yes, very, very often, if you get that person who's just sweating, the ah, like that kind of, very, very dramatic febrile thing. Yeah, it's probably going to end up being malaria as the fevers kind of, very high. They come and go with like crashing kind of a thing, which means they come up sharply and then they go down very hard.
So here's the project. Each volunteer had to put their arm over a mesh-covered container filled with 200 mosquitoes and who received the CRISPR modified parasite that had none of the infectious properties.
Yes. So
Then, after some time and presumably a lot of convincing, or maybe not,
mhm,
who was going to do this the first time? They're probably going to do it a second.
sure.
The second round of mosquito bites had real unweakened malaria. So they threw them in and said, "We hope this works."
Yeah. Well, the practice of using volunteers, so healthy volunteers for volunteer infection is not at all a new concept. And as long as you pre-screen your patients to make sure that they can tolerate something like this and not get hurt, then it's perfectly fine. It's a great way to do things, actually.
Out of the 14 who were exposed to real malaria, 7 came down with the disease and were treated with anti-malaria medication, meaning this vaccine was only 50% effective and didn't last for more than a few months.
This does happen, of course, where we have to, sometimes incrementally get our vaccines better and better over time, especially if we're working with, a protein or a parasite in this particular case that the immunogenicity is kind of weird. I mean, the damn parasite is evolved to evade our immune system and just get in there without getting shut down. So this one, it's not an easy vaccine to engineer.
Although 50% is not terrible given the alternative of no prevention.
Yeah.
So,
Like I said, I mean, the previous vaccine, the Muscarix, is 30% effective, and that was good enough to license.
there you have it. We've now taken a very old disease and one that has been more of a threat recently. But Santosh, you're an infectious disease doc, and I know that you're going to want a disease that's sexy, something that's flashy, has a big stylish announcement of itself, but
Oh,
more
sure.
importantly, may now be treatable via vaccine.
That would be wonderful. Yeah, it would be really, really cool. I actually I appreciate vaccinating against malaria because it is such a worldwide killer. And I know we don't see it as much here in the Western world and in the United States, but having a good vaccine against this disease means that we're treating a very, very clinically important disease.
So, what disease do you think would be impressive enough to warrant your attention?
But something that, kind of strikes fear into everybody. So maybe one of these, like, outbreak type of diseases, like your Lassa fever or one of those, like Ebola.
I can think of no disease I'd want a vaccine for more than something that could literally make you bleed from your eye sockets.
Yeah.
I mean,
Absolutely.
not
Yes.
commonly, but it's
Yeah.
possible.
Yes. Yes.
Let's be very
It,
clear. I mean, it's you're going to have a lot of worries, but that shouldn't be one of the more immediate ones.
Yes. So most people with Ebola get very, very ill. The mortality can be insanely high with Ebola, but the hemorrhagic phase that it's famous for, basically you're unable to control clotting from multiple sites, and wherever you can bleed from, you bleed. And it can be very, very scary. Even going in to treat these poor folks, it was a scary proposition because you'd be putting everybody who tried to treat these folks at risk. So, yeah, you would do your best to stabilize, hydrate, get these folks supportive care until their hopefully immune system could kind of ride through. It was not a very good proposition when you got Ebola. Still not.
And so, in 2018 or 19, we actually had developed a Ebola virus vaccine
Sure.
based on a specific outbreak in Kivu, Zaire.
Okay, gotcha.
Um, and that had been used extensively in that epidemic under a compassionate use protocol,
Hmm.
which, to briefly sum up, is something that basically says these people are absolutely going to die in very short order, almost regardless of what we do. So let's try this drug on, with their consent in case it helps.
Yes.
So that is the very abbreviated, beyond Cliff's Notes version of
Yeah.
compassionate use.
Yeah. It's
And
essentially, yes, we understand this has not passed, all the trials and approval, but the concern is bad enough, and the potential upside is so close to any kind of risks that you can come up with because the disease itself is so deadly that we're going to go ahead and try.
so, still holding the record, I believe, once it was approved under this compassionate use, the European Commission granted a conditional marketing authorization, and the pre qualification came fewer than 48 hours later, which makes it the fastest pre qualification process ever conducted by the WHO, not the band, the World Health Organization.
The World Health Organization, yeah. Thank you for clarifying.
And
Yeah, I
only a month
suppose we
later,
can approve it, man. Yeah.
it was approved in the European Union in November 2019 and the US in December. Then Merck took it over, and it's largely distributed more through Africa. Just like with COVID, because I think we can use that virus language that everybody has had 3 years to get to learn.
We do have folks over here who are first responders and then laboratory and support staff and then healthcare personnel who need to take care of imported cases of Ebola, and that does happen from time to time. For instance, the center that I work at, Josh, is called a special pathogen center, which means that we're the site over here if you have any kind of a thing where emergency, scary, ultra scary, very contagious diseases coming in, we have all the protocols and personnel in place in order to contain it and treat the people. So we can have people over here who are authorized to get this vaccine who are not necessarily over in Africa.
So, just like with COVID, the component of the virus that triggers the immune response is a surface glycoprotein. So, kind of like the spike protein that we have been seen and accustomed to.
Yeah, well, one advantage to Ebola in terms of engineering a vaccine is that the genome is quite workable. So, Ebola genome is not very big. In terms of other viruses and stuff, 18 to 19 kilobases long. That's it. It's this tiny little, very simple virus. We still drives us insane how much damage this tiny little thing can cause. So
So,
engineering out of this genome and making the protein can be quite easy.
so the Ebola virus called Ervebo.
Yeah.
Ervebo,
Yeah.
it's the virus.
the
It's
the
like the
vaccine.
Swedish chef vaccine.
Yeah, exactly.
Today we're going to make an Ervebo for the Ebola.
Yeah, it's Ervebo, Ervebo. Yeah, Ervebo.
Uh, yeah. So it's an Ervebo thing to get. Um, It is not possible to get infected with Ebola from the vaccine because it only
Right.
has a single gene, and that gene is just for the little flag that helps it hook on. And what it's replacing is the gene that helped the virus it's being carried in hook on. So you're basically Trojan horsing just a little protein that will laser target or laser paint the area for your immune system.
Yeah. And your immune system's able to recognize that little spiky thing and say, all right, if I see that thing again, I'm going to knock it down before my host can become overwhelmingly sick. And Josh, this is another one of these where, we had to be really careful because the virus causes its own pathology. And then there is, in a later phase of the disease, immunopathology that goes along with Ebola, where our own immune system, does some of the damage. So, in engineering this particular vaccine, we again had to be really careful that the vaccine itself didn't provoke this type of a response. And it worked, but you know, the trade-off in this case, because we had to strip it down so much, is the efficacy isn't fantastic. But it's definitely better than nothing.
There's also been very few cases, thankfully, to really test it on, and
Yeah.
we should have our friendly neurologist come on and talk about her research again at some near future point.
Oh,
Uh,
absolutely. Yes, yes. Jean, yes, who worked at the NIH, working at the NIH, I believe,
yes.
on the neurological sequelae of Ebola, which a lot of people don't think about because we usually think about the hemorrhagic stuff.
So, but right now, if you want an Ebola vaccine, too bad because you don't qualify unless you are one of three kinds of people. There's three kinds of people in this world
Okay. Those who
that
can count and those who can't.
one is Ebola virus disease responders. Because
Hmm.
those are people who you definitely want to make sure have been vaccinated. They'll take whatever chance they can get.
Yeah.
Next, lab and support staff working at biosafety level 4 that
Hmm.
handle specimens that might contain any kind of infectious disease, not just Ebola. So you're talking highly infectious, Mission Impossible style
Yeah.
labs.
BSL-4 protection that you need for that type of an isolation is the one that people see in the movies with the full, hazmat suit and everything, and then a separate air supply going into the suit which is completely sealed. A external air supply which is going like via hose, outside of the room so that you're not even having a chance of like, breathing the air in the room.
And
Yeah.
finally, healthcare personnel at designated Ebola treatment centers, in which we interviewed the person who runs one in an
Ah.
episode a while back. Some like it hot, or the
Oh,
containment
yeah.
zone. I don't know. I have a lot of pun titles. It can be difficult to keep track. And of course, booster doses are also being developed. But I think the really exciting thing, so that of course dates back to 2019, which is ancient history in science time. But as of I'd say around almost, but not quite a year ago, in October, September of 2022, there were pills in phase 2 clinical trials for oral Ebola vaccine.
Oh, okay. I actually did not know about that.
So again, still in trials. We are still a ways off, um, but it is being developed by a company called Vaxart. But they were trying to make essentially an oral vaccine that could be freeze dried into a tablet as an example of emerging cold storage advancements. So the problem is making it a temperature stable, and they were in phase 2 trials, and then of course the pandemic sort of took over all the cold storage facilities, and it
Sure.
looks like it is in, I don't know, lost in limbo right now. Oh, because they took over making COVID vaccines. It's essentially a oral vaccine startup. Wish them the best of luck. We'll have to see what ends up happening. It'd be a lot nicer to take a pill for Ebola than to get a shot. Are there any other vaccines that you think we should go over, Santosh?
Let's see. We got some, malaria, which is a worldwide killer, very, very important. We got vaccinating against Ebola, which is super scary and sexy, but probably in the long run not as useful as we said. Ebola is kind of patchy and comes in small outbreaks, but still important. We talked about respiratory syncytial virus, which affects so many people, young and old, and the development of the vaccine for older people and the ones coming up for younger people. It's a pretty good, to cover a lot
Because
of modern infectious diseases. Yeah.
because I don't want to drag this out,
Okay.
because then you'll be more inclined to ignore these sort of things in the future. And of course, that's the subject of our final study. What a twist!
Oh, okay.
Vaccines that provoke or prolonged immune response may actually
Oh,
give you
okay.
better protection. So, most vaccines are meant to give a quick immune response. That's why, the next 24 hours after receiving the COVID vaccine, you may notice some fevers and chills or just general soreness from your annual flu shot you should
Sure.
be getting annually.
Okay.
Or even childhood vaccines, they tell you to watch within the first how many hours, Santosh?
Uh, Usually within the first 24 to 48 after you get your shot.
Yeah. So these are all quick immune responses, but a longer one may actually allow the B cells or memory cells formed in the bone marrow, which can prevent future infections, to stick around longer.
Oh, you're talking about instead of provoking a kind of sharp, quick response, this is one of those that will provoke kind of a slow burn of a vaccine response, like over a longer period of time. And we do sometimes mimic that, Josh, with a booster shot. So you give your first vaccine, and then you allow 2 to 4 weeks for the immune system to cool off a little bit, and then you provoke the immune system again with the same antigen, and just as kind of a reminder. So COVID-19, everyone get out there, get their booster shots for extra protection. It's kind of a delayed, but I don't think what you're talking about, like a more prolonged immune burn, which is different.
Okay, well, our immune cells, being part of us, get
Mhm.
better with each iteration. They learn.
Yes. Yes.
Um, and the more times they're exposed to a particular disease, the better they get, or the longer they're exposed, the better they get at producing specific antibodies that say, hey, it looks like this, like creating a police sketch.
Yes. Uh-huh. Yeah. And then you're right. The antibodies become what we call more avid over time, meaning that their precision kind of lock and key mechanism with the antigen gets closer and closer so that you form antibodies which lock more tightly with the antigen are better at recognizing
They
when
become
you have
more
an
fanboys of a disease until they evolve into paparazzi and no disease can make it in without being surrounded and
yeah,
harassed. And in the meantime, when
yeah.
they're not being used, they're stored
Mhm.
in the bone marrow at, convention centers.
Yeah, and in your lymph nodes and many other sites where B cells hang out until ready to go.
So researcher David Tarlington at Monash University in Melbourne, Australia,
Hmm.
vaccinated some laboratory mice just with a standard research antigen, presumably with a barcode on the side of it somewhere,
Sure. Okay.
and then euthanized them a few weeks later to study the bone marrow in their legs, which, as we said, is a known place for B cells to gather.
Yes, or and to be generated as well. Yes.
And they put like a little timestamp die in it so you could see when B cells were recruited to become memory or plasma cells. And the researchers found recruitment didn't just happen at the end of the immune response, but
Hmm.
every single day. On average, a new cell is recruited every hour. So the longer the immune response lasted after the shot, the more plasma cells were accumulated. And remember, each generation of cells is going to be better than the previous one. So the
Hmm.
longer you prolong the immune response, the more cells you accumulate. The best ones are at the end. So if you're looking for months long immune responses rather than weeks long, the length of time to have that immune exposure should be taken into consideration.
Sure. Yeah, and this may be more optimal for certain infections, less optimal for others. There is a phenomenon of immune exhaustion if the immune system is just provoked and provoked and provoked for way too long. It does use up resources and calories, and if you have an ongoing infection, you can potentially get a super infection with something else, even if it's very common, and you can get even worse than you did before. So you do have to balance out the benefits and risks here, but it's a very interesting idea, and it's definitely very different from pretty much how every other vaccine provokes the immune system right now.
So, one of the ways that may change is instead of going into the doctor's office to receive a shot or several shots, and then expect a couple days of general unpleasantness, imagine a skin patch with a bunch of small microneedles that you wear for maybe a week or two, and you feel maybe mildly unpleasant. But then at the end of it, you are, functionally protected or immune for months and months, if not the remainder of the year.
Yeah. And we need some sort of answer, and this may be it, to the phenomenon that we face otherwise. Yeah, and we've seen this with our wonderful COVID-19 vaccines. They do have excellent protection, 2, maybe 3 months out after you get your shot or even your booster. But the efficacy does fade over time, sometimes modestly, sometimes quite a bit. So anything that we can do to prolong our immune memory and to sharpen it using a single vaccine rather than having to boost over and over and over would be just wonderful.
So that's it for this week. As always, we love to hear your comments, questions, and feedback. If you'd like to support us spiritually, emotionally, or financially, links to do that are in the show notes, along with links for further reading. If you really like to hear us,
Yeah.
sign up for the mailing list at travelmedicinepodcast.com. I made it
Yeah.
as simple as possible.
Yeah.
And then we can tell you when we're doing stuff, and we can get opinions from you on what stuff to do.
Yeah, absolutely.
Our theme music is composed by Rachel Leisure. This show is produced by me with a lot of help from Dr. Santhosh and friends. And until next time, keep a song in your heart, soap on your hands, some shots in your arm, and you have so many to choose from. Spin a globe, and once you've done all those things, pick a place to go, and happy travels.
Bye, everybody.